Systems of equations by substitution. Systems of equations are two intersecting equations whose variables are the same, and the solution is written as an ordered pair. So instead of graphing them, we're going to algebraically solve to see where those two lines are going to actually cross at. At that point of intersection is an ordered pair, and that's what your solution is going to be. So, substitution is simply replacing a variable with a known value or an expression. More times than not, it's going to be an expression like 3x plus 8 that you're going to replace it for. So, very simply, if I have 4x, and if it tells me that x is equal to 3, that's saying that x is the exact same thing as 3. So I can take that 3 and replace it in the x's place. So now when I solve, 4 times 3 is going to give me a 12. This is an oversimplified example of what we're going to do, but the same rules and concepts apply. So if we look at example 2, for example 2, it says y is equal to 4 and 2x plus y is equal to 8. For this one, I know that y is the exact same thing as 4. So I'm going to take this 4 and plug it in to that y of my second equation. So when I plug it in, I now have 2x plus 4 is equal to 8. So I'm going to solve for x. Again, if I want the 2x by itself, I'm going to have to subtract 4 from both sides, so I'm left with 2x is equal to 4, and then you would have to divide 2 on both sides, because 2 divided by 2 is going to cancel, so it's going to give you x is equal to 2. When I write this as an ordered pair, my x that I just solved for is my 2, and my y is a 4 because that was given at the top in the first equation. Y was 4, so all I had to do was solve for my x. In this next example, I have y is equal to 6x minus 1, and 3 plus y is equal to 8x. So again, since I have 6x minus 1 is the same thing as y, I'm going to take this whole expression and plug it in for that second y. So now this second equation is written as 3 plus 6x minus 1 is equal to 8x. So I'm going to solve for my x value. So I can combine like terms. 3 minus 1 is going to give me a positive 2. If I want to get my 6x by itself, I would have to get rid of, or I would have to move the 2, because now I have one constant. So I want that constant by itself, so I'm going to have to subtract 6x from both sides. When I subtract 6x from both sides, I get 2, that constant comes down, is equal to 2x. Now I'm going to have to divide both sides by 2, so I get x is equal to 1. So here's my 1 down here for my x. Now that I have my x value, I can plug it in to either of these two equations to solve for my y. I have worked it out both ways. This way, if I plug in my 1 for x, 6 times 1 is 6, subtract 1 is going to give you a 5. So that's how I get my 5 for my y value. Or, like I said, you could have plugged it into the second equation. So if I have 3 plus y is equal to 8 times 1, that's going to give me 3 plus y is equal to 8. When I subtract 3 from both sides, I'm going to end up with 5 as well. So again, it doesn't matter which equation you plug it into, you're still going to get the same value. So let's work out example 4 together. If I have y equals 5x plus 2 and negative 9x plus 4y is equal to 19. I'm going to take this whole expression and plug it in for this y. So when I rewrite the second equation, I have a negative 9x plus 4 times this whole piece, 5x plus 2, and it's still going to equal 19. So now orders of operation tell me to do my distributive property, negative 9x plus 20x plus 8 is going to be 19. On the left side of the equal sign, I can combine my negative 9 and my positive 20x. So I'm going to get 11x plus 8 is equal to 19. Now I want to isolate my 11x, so I have to get rid of my 8 by subtracting it on both sides. So I'm left with 11x is equal to 11. Divide both sides by 11, so I get x is equal to 1. So again, that's the first part of my answer. So now I can take this 1 and plug it in to either of the two equations from the top. If I plug it into this top one, I'm going to have y is equal to 5 times 1 plus 2, so y is equal to 5 plus 2, which means y is going to equal 7. Or I can plug it into the second one. Negative 9 times 1 plus 4y is equal to 19. So I have a negative 9 plus 4y is equal to 19. I'm going to add 9 to both sides. 4y is going to equal a positive 28. So then when I divide both sides by 4, my y is going to equal 7. Again, your answers are written as ordered pairs, because if I were to graph these two lines, this point, 1, 7, is where those two lines are going to cross each other. So that's your solution.